Okay, for this discussion, we will be focusing about another flow measuring instrument, which we call nozzle. I know most of you are familiar with the nozzle because we usually see it in our daily life, or we are familiar with its uses. No? So a nozzle is a converging tube connected to the end of a pipe or hose and is used for engineering practice for the creation of jets and streams for a variety of purposes, including metering. Okay. So, isa sa mga common na makikita nyo is mga common na nozzle na makikita nyo is yung sa mga fireman, no? Para maapulan nila yung apoy, yung dulo ng kanilang mga hose ay isang nozzle, no? Ah, para makontrol yung flow and mapaabot nila kung saan man need umabot yung tawag dito, yung tubig sa apoy na kanilang inapula, no? So like yung Venturi meter natin, meron ding losses, no? Kung makikita nyo rito sa figure natin, meron tayong from point 1 to point 2, which is the base and the tip of the nozzle, no? And in between those points, meron din tayong mga losses na ina-account, no? So meron tayong tinatawag na head loss in a nozzle, which given in the formula shown. Ito, Hn is equal to the quantity of 1 over Cv squared minus 1 times the velocity head of the actual velocity. Okay. So, ano ba yung coefficient of velocity? So, yung coefficient of velocity can be computed by the ratio of the actual velocity to the theoretical velocity. So, similar to the coefficient of discharge, yung coefficient of velocity is just a correction factor, okay, na minumultiply natin sa theoretical velocity para makuha yung actual velocity. Okay. So, yun. Lagi natin tatandaan, no, kapag similar doon sa case natin sa Venturi meter, ganun din. Yung mga binigay ng libro na mga formulas is madami. So, hindi natin sila kailangan tandaan lahat as long as kaya nating operate itong mga gantong klaseng problem gamit yung Bernoulli energy equation. Okay? So, dito, no, at tandaan natin na kapag in-account na natin yung head loss in a nozzle doon sa Bernoulli energy equation, hindi na natin kailangang i-apply pa yung coefficient of velocity sa dulo, no? So kapag in-account na natin siya, as in inag na natin yung h sub n doon sa Bernoulli energy equation natin, okay na siya. Okay, ibig sabihin nun, actual na yung mga ginagamit natin na mga values, hindi na theoretical. Pero kapag hindi mo ginamit, so you would still have to apply yung or i-multiply yung theoretical velocity na makukuha mo dun sa Bernoulli energy equation to the coefficient of velocity. Okay? So, again, similar dun sa ginawa natin sa Venturi meter, kukunin lang ulit natin yung problem na binigay na example dun sa book para makita natin paano ba kinumpute gamit lang yung Bernoulli energy equation instead na i-memorize mo lahat ng mga formulas na binigay ng libro. Okay? So, lahat naman ito ay nagmula lang sa Bernoulli energy equation. Okay. So, let's read the problem. So, sabi, so meron daw nozzle, no, which is 10 cm by 4 cm. It is trained vertically upward at a point 30 centimeters below the tip. The pressure is maintained at 145 kPa. If the available power in the jet is 2.6 kilowatts, find A, the height through which the jet of water will rise. So, hanggang saan daw siya pwedeng umabot, neglecting air friction. B, compute for the value of the coefficient of velocity. And C, the diameter of the jet 6 meters above the tip of the nozzle. Okay. So, yung yung item A, hindi pa natin kailangan yung Bernoulli energy equation dyan. Kailangan lang natin dyan ay yung equation of continuity. No, kailangan natin dyan. Pero, kailangan natin munang masolve kung ano yung mga velocities dyan para magkaroon tayo ng kailangan muna natin makompute kung ano yung discharge para makakuha tayo ng actual na measurement ng H. So, start natin sa Bernoulli energy equation muna. No? So, that would be, say, focus muna tayo doon sa loob ng system, which is yung 0.1 to 0.2, no? So yung 30 centimeters na yon. O doon muna tayo para makompute muna natin yung yung coefficient of velocity, then yung actual na discharge, then yun ang gagamitin natin para ma-solve yung mga actual na mga velocities, actual na mga flow. Then doon pa lang natin masosolve si height H. Okay? So, sulat natin yung Bernoulli energy equation. So, from point 1 to point 2, so mahalaga na nakanutin nyo kung ano yung kinukuha nyo. So, from point 1 to point 2, so we know that V1 squared over 2G plus P1 over gamma plus Z1 minus head loss in the nozzle, HN. I-account na natin siya. So, ibig sabihin na makukuha natin dito ng mga velocities. Yung V1 natin na makukuha dyan is actual velocity. No? Then, is equal to V2 squared over 2G plus P2 over gamma plus Z2. No? So, yung V1 and V2 dyan is actually mga actual velocities na. Okay? So, isa-isayin natin yung mga values. So, yung V1 squared, hindi natin alam, pero may makukuha natin ng value na. No? Yung P1, given yung P1, which is 145 kPa, Z1 is negative 0.3. Negative 0.3 meters. Yung HN is yung formula ng HN kanina, which is 1 over CV squared minus 1 times VA squared over 2G. Tapos yung B2 squared over 2G is, may value din yan, masosolve natin yan. Then P2 is 0 dahil exposure sa atmosphere. Then Z2 is 0 since nandun yung datum natin. So, ang natira na lang sa atin ay V1 squared over 2G plus 145 kPa over gamma minus 0.3 meters minus 1 over CV squared minus 1 times VA squared over 2G is equal to V2 squared over 2G. Now, sabi natin kanina, yung mga velocities na nakuha natin is definitely are actual na dahil in-account na natin yung head loss in the nozzle. So, we can say that VA is equal to V2. Okay? So, So, kung ganon, pwede natin yung i-substitute doon. No? Magiging, yung VA is equal to V2. Pwede natin palitan yung V2 ng VA. So, ang natitira na lang sa atin ngayon na variables is si CV, VA, tsaka si V1. No? No? So, pwede pa rin natin i-convert or i-express si V1 in terms of V2 na equal sa VA gamit yung continuity equation. No? Alam naman natin that yung Q sa point 1 is equal sa Q sa point 2. So, dito tayo sa baba mag-focus. Q1 is equal to Q2. So, that would mean that Q1 is A1 V1 is equal to A2 V2. Since parehas circular pipe yan, makakancel yung pi over 4. Ang matitira dyan is D1 squared V1 is equal to D2 squared V2. V1 is equal to D2 squared V2 over D1 squared. So, V1 is equal to, ang dito natin is, ano sabi? 10 cm by 4 cm. So, 10 cm yung D1, 4 cm yung D2. So, 0.04 meters squared over 0.1 meters square V2. So, pag kinuha natin yung ating calculator, lalabas natin yung calculator. Ito. Yan. No, that would be 0.04 square over 0.1 squared. That would be 0.16. 0.16 V2 or V1 is also 0.16 VA. No, dahil doon. So, ang matitira sa atin ngayon is that magiging 0.16 VA squared over 2G plus 145 kPa over gamma minus 0.3 meters minus 1 over C V squared minus 1 VA squared over 2G is equal to VA squared over 2G. So, napansin nyo, dalawa na lang yung variables natin, VA tsaka CV squared. Kapag sinimplify natin lahat ng may VA, no, yung 0.16 VA tsaka over 2G tsaka yung VA sa right side ng equation, mas-simplify pa natin yan, pero later on na natin yan gawin. Dahil kailangan muna nating makuha yung value ng CV para makuha natin yung C. Kailangan natin makuha yung value ng CV para makompute natin yung actual na flow, no? Para makompute natin yung CV. Sorry, ulit. Kailangan natin makompute yung value ng actual velocity para makompute natin yung CV o yung coefficient of velocity. So, para natin gagawin yun? Gamitin natin yung isa sa mga binigay na given is yung power in the jet, which is 2.6 kilowatts. So, if the power is 2.6 kilowatts, so ang formula ng power is P is equal to Q gamma E. Okay? Alam natin that Q is equal to AV. And this time, ang pinag-uusapan natin na V is actual velocity and yung area ng mas maliit. Okay? Kasi yun din yung area ng jet eh. Diba? Yung kung ano yung area ng nozzle, yung tip ng nozzle. Okay. So, let's try to solve this. So, P is equal to A2VA. Multiply natin sa gamma. Then, yung E is yung energy sa point 2. No? Ano ba yung E? Kinuha natin yung energy at point 2. That is the energy at the nozzle. We have V2 squared over 2G plus P2 over gamma plus Z2, in which alam natin that P2 is 0 and Z2 is 0 dahil nasa datum siya and exposed siya sa atmosphere. So, rewriting again, we have P is equal to A2VA gamma times VA squared over 2G, since V2 is equal to BA. So, substitute natin yung mga values. A2, pi times 0. Ano size nga ulit yun? 0.04 squared over 4 times VA times 9.81 kilonewton per cubic meter, then VA squared over 2G. So kapag simplify natin yan, we have pi times 0.04 squared over 4. Yung mga ano lang, yung mga constant lang, 9.81 divided by 2 times 9.81, 2G. So naka-account na natin lahat. That gives us ang matitira dito is VA squared BA cube times yung numerical coefficient ng product ng lahat ng numbers. Then alam natin that this is 2.6 kilowatts. So if that is 2.6 kilowatts, we have to multiply 6.28 times 10 raised to negative 4. So we have VA is equal to, store natin to sa A, 2.6 divided by alpha A, and then kunin natin yung square root. Yung mali ba akong nagawa? Ulit. Pi times 0.04 squared over 4 times 9.81 divided by 2 times 9.81. Tama pala. Hindi pala to, this is cube. Okay, VA cube. So that would give us alpha A divided by 2.6 kilowatts. Ulit. 2.6 kilowatts, 2.6 kilowatts over alpha A which is equal to 413.02852. Tapos kunin natin yung cube root niyan. The answer is 16.0545 meters per second. That is the actual velocity. Store natin siya sa B. Store sa B. So since naka-store na siya sa B, masosolve na natin. Sorry. So since naka-store na siya sa B, masosolve na rin natin si CV kapag sinubstitute natin si VA dun sa taas. No, substitute 2, this one. Kapit na tayo ng ibang pen. So that gives us kapag nilagay natin to sa yung CV sa right side ng equation, it would give us the value of parang ganyan ang mangyayari. 0.16 VA squared minus VA squared over 2G plus 145 kPa over gamma minus 0.3 meters is equal to 1 minus C V squared minus 1 times VA squared over 2G. So that would be it. So, ang gagawin natin is lagyan natin siya dito 0.16 VA is nasa alpha B squared over 2G minus alpha B plus 145 kPa over 9.81 minus 0.3, tapos multiply natin lahat sa 2 times 9.81 divided by VA squared alpha B squared. Kamutan natin yung square dito. Then, magka-plus tayo ng 1. Ba't nagsi-syntax error? Anong mali ko sa syntax? Anyway, may tayo mag-add ng 1. Tapos mag-add tayo ng 1. And get the reciprocal. Ulit. Then get the square root. 0.94 CV is equal to 0.941599. Say that is the coefficient of velocity. Nasagutan natin yung V. Then since nakuha natin yung V, meron na tayong actual velocity we can also solve for the Q. Hinahanap ba yung Q? Find the height and diameter of the jet. Okay, so hindi pala natin kailangan ng Q. So, height through which the jet of water will rise. So, para dun sa second part ng ano na yun, store ko to sa C. Para dun sa height through which the jet of water will rise, gagamitin lang natin ng Bernoulli energy equation from point 1 to point 4. Oops. Add tayo ng... So, this time, to solve for the height, no, kailangan natin ng Bernoulli energy equation from point 2 to point 4. Point 2 to point 4. So, we have V2 squared over 2G plus P2 over gamma plus Z2. May head losses. Wala tayong losses kasi nineglect natin ng air friction. We have 4 squared over 2G plus P4 over gamma plus Z4. So, isa-isay natin. V2 squared over 2G, meron tayong V2 no, which is equal to VA. So, meron tayong value niyan. Meron tayong P2 which is 0. Z2 is 0 din dahil siya yung datum. And B4, no? B4, the value of B4, since ang hinahanap natin is kung hanggang saan siya maximum pwedeng tumaas or yung magiging tawag doon, maximum height ng jet. Alam natin doon sa engineering dynamics natin is that kapag nasa peak na, ang velocity niya ay 0. Tama? Tapos yung P4 dahil exposed to air, 0 din. And Z4 is equal to the height H. So kapag sinimplify natin to, ang natitira na lang ay V2 squared over 2G is equal to H. So our V2 is equal to VA squared over 2G since V2 is equal to VA. So yung value ng VA natin kanina is nakastore sa B. So ganun lang siya kadali. H is equal to alpha B is equal to 16.0545 meters per second square over 2G. H is equal to that is equal to 13.137 meters. So that is the answer. Yan ang maximum height. Now, punta tayo sa huling hinahanap. Ang huling hinahanap sa atin ay diameter of jet 6 meters above the tip of the nozzle. So, for this one, kailangan lang natin ulit yung Bernoulli energy equation from point 2 to point 3. So, from point 2 to point 3. So, we have V2 squared over 2G plus P2 over gamma plus Z2 is equal to B3 squared over 2G plus P2 over gamma plus Z3. Okay. So, isa-in root natin. V2 squared, meron tayong value. P2 is 0. Z2 is 0. V3 is meron tayong value. P3 is 0 dahil exposed sa atmosphere. Z3 is equal to 6 meters. Dahil ang hinahanap natin is 6 meters above the tip of the nozzle. So, ang natitira sa atin dyan ay V2 squared over 2G is equal to V3 squared over 2G plus 6 meters. So, ang hinahanap sa atin ay diameter of the jet 6 meters above the tip of the nozzle. So, kapag nakuha natin ng velocity, pwede natin kunin ngayon. Pag nakuha natin ng velocity 3, pwede natin siyang gamitin ngayon to compute for the area that would give us the diameter of the jet. Okay? So, yung V2 natin, so with this, makukompute natin ng V3. Alam natin that V2 squared over 2 times 9.81 minus 6 times 2 times 9.81 then get the square root. V3 is 11.8335 meters per second. So, store natin siya sa D. Store at D. Para balikan natin siya later. Then, Q3 is equal to Q2. So, A3 V3 is equal to Q2 V2. A2 V2. A2 V2. Then, dahil nga bilog yung pipe, bilog din yung jet. No? So, makakancel yung pi over 4 sa formula ng area ng circle. So, that gives us D3 squared V3 is equal to D2 squared V2. So, ang hanap natin ngayon is si D3. D3 is equal to square root of D2 squared V2 over V3. So, kapag sinubstitute natin ng mga values, D3 is equal to square root of D2. The diameter 2 is 0.04. V2 is 16.0545. Over V3, which is 11.83335 meters per second. D3 is equal to 0.04 squared times alpha B over alpha D. D3 is equal to 0.04659 meters, or D3 in centimeters, that is 4.6591 cm. That is the answer. Okay? So, ganun lang kadali yung mga ganyang klaseng problems basta kabisado mo yung Bernoulli energy equation. Okay?